Hello everyone, it's Richard here. In this video today I want to talk to you about making your very own heated dry box, just like the one I've got here. It's really easy to do. You only need a few things you can buy off of eBay and some design files which I'm going to post on Thingiverse and Imagine. So we'll get onto that in just a moment. The combined cost is about £15 or 20 US dollars, so it's really easy to make. It's heated, so it has actually got an electrical connection and monitors both temperature and humidity of your filament while you're using it. Okay, so before we get into that, I just wanted to go over a little update on the MasterSpool concept that that I proposed in my last video. It got a lot of feedback, updates, and some tremendous support from the community. So I'll just quickly go over that. If you want to skip that, jump to this timestamp in the corner here and you'll go straight to the dry box tutorial and skip all the MasterSpool stuff. So in my last video I explained the concept of MasterSpool, and that really very simply is a two-piece spool and a coil of raw filament that requires no other packaging or very minimum packaging. Lots of interest in the community, lots of feedback, and immediately within hours of posting the video I was having filament manufacturers contact me to say that they were going to try out the idea. I originally thought that would take them weeks, months, maybe even longer. What I was really surprised about was Das Filament in Germany actually got back to me within probably 4 hours or so to say that they had tried the idea, put it on their machine and worked out a way to do the coil of material, and actually they used 1.75 millimeter filament material as well, which was really good because I really wanted to test, see if that would work. I had used 3mm or 2.85 N-Gen. So they came back with a picture that literally went from this to this. It showed their actual working coil, which is really impressive. And they like the idea, so they're going to move ahead. A few other people have suggested great things like using possibly a cardboard tube in the middle just to give the filament a little bit more support, the sort of thing you'd find on a roll of tape, that sort of thing, just to give that extra filament a bit of support. It might be easier to then put onto the MasterSpool system. And a lot of other people got a little bit confused with, do they need to print these? You can print them. The design files were put up on Thingiverse and Imagine for that exact purpose, but the point was really that manufacturers would probably sell these either injection molded, because you wouldn't need so many of them. You will need quite a few because, as people pointed out, they'll use half a spool. They may need to either take that spool off or leave it on the MasterSpool and use another one to finish off a different type of material first. That's fine. However it's done, it doesn't really matter whether you buy the MasterSpool from a supplier or you print your own. Some companies are already halfway there. Colorfab for some time now has had a two-piece spool that clips together, a bit like MasterSpool, that's made of biofoam. So all they need to do is actually then move ahead and produce core coils in minimum packaging. So I'm really hoping to hear from Colorfab whether they think that's viable and possible with their biofoam spool that they've already developed. We spent quite some time talking about that over the last few years, so I'd love to see that happen. And yeah, keep an eye out on what's going on with MasterSpool. I will update you again if anything more happens, but at the moment it's looking really good. Loads of really great filament manufacturers. We've got Fishy Filaments who do currently recycle nylon fishing line, so it's they collect it from the environment, recycle it and turn that into 3D printing filament. They're very interested in the MasterSpool concept, and we've got quite a few others as well that have also shown quite a lot of interest, loads of users and loads of great feedback. So thanks to everyone who's commented and given me lots and lots of messages. Literally I've just got hundreds and thousands of messages from people all over, which is really great. So thanks ever so much. Okay, so that's MasterSpool, and we'll get back to the point of this video, which is to show you how to take care of your filaments a little bit better while you're actually using them. Okay, so the idea of the heated dry box came after a visit to E3D about 3 or 4 years ago, and they basically had a big plastic tub filled with some really interesting materials, lots of nylons, exotic materials, things that are a little bit tricky to print at the time. And they had a reptile heater thrown on the top of the box just to keep the environment inside there nice and warm and cozy for all of the materials. Really great for things like Tolman nylons and stuff like that. So fast forward a few more years and I'm using obviously a lot more of those types of materials that are slightly moisture sensitive, especially PVA, loads of nylons, which I've been using for some time, but always having to dry them out before use. And certainly the Polymaker Polysmooth, which can really benefit from keeping nice and warm and cozy while you're printing it as well. So that's how the sort of background of the DryBox thought process came about, and I use a Reptile heater in this DryBox just to give you the connection of why I'm talking to you about the E3D visit. So then we move on to the back end of last year, where Polymaker released a similar sort of DryBox for their materials. Not particularly expensive, around 55, oh, it's probably a bit more than that, maybe 60-70 pounds here in the UK. But it is, I saw it at the TCT show, and it's basically a box that controls the environment with some silica gel packets and a little monitoring device, very similar to this sort of thing, which has temperature and humidity. And it was okay, you know, it's designed for their materials. It can take the great big 3 kilogram roll of Polymaker Polylite PLA, so that's big 3 kilogram rolls. Take one of those, or it can take 2 of their 750 gram rolls. It rolls on rollers, which I've never really been that keen on, because you can't put things like the small Tolman spools on. They just won't fit on the rollers and they won't work. So I wanted something that would allow a normal spool mount system that I could put normal 750 gram, 1 kilogram and other types of smaller spools on. So that was my design brief. I wanted a box that was heated. The Polymaker one hasn't got any electrical connection, it's just got a monitoring device. I wanted to use desiccant gel because that's a really good way to pull moisture out of the air, and I also wanted to be able to use it not just for storage of the materials, but while the machine's printing, so it needed to be able to feed the material as well. So I started off with looking for boxes, and the first thing you'll need is an 11 litre, something around that sort of size box. There's loads and loads of these on eBay and places around. This one was actually manufactured in the UK. It's a Demreal, oh no, it's actually, no, this one, there were some on the UK. This one was made in Turkey, Demreal plastic, 11 litres, so nice and easy to get hold of. Not very expensive. These were about £6.50. I got 2 for, I think, about £14, including delivery, which is great. So that's the first thing you'll need, is a box. It doesn't have to have a completely sealed lid. You don't have to have a rubber seal or anything like that. It's not that important for these types of boxes to be completely hermetically sealed. It's actually okay if they've got a few little cracks that can just allow the warm air to escape. That's fine. So the other thing you'll need is a heater element, and I decided that because of that trip to E3D, and they had a big, quite a large heater element, but I wanted a smaller one. So this is a 28 centimeter by 15 centimeter 7 watt Reptile heater, and you can pick these up. I mean, literally they're just a few dollars in China. I actually paid a little bit more and got this one slightly quicker, and I bought two at a time, but still they were only about £4 or so, which is really only less than five US dollars. And they're pretty good. I mean, the one thing I would say about buying any electrical devices is be comfortable and happy with what you're buying. If you feel that buying it from a local pet shop as a heater that you're gonna then use because it's got an electrical connection, a branded part may be more suitable if you're a little bit unsure. I got this one, immediately took apart the controller just to make sure it was all okay. Inside there's a little rotary on-off that you can turn the power on, and you can actually then step this one up and down. It's only 7 watts anyway, so I keep it all the way turned up. It has got a little triac in there that's doing some power delivery to this sheet and actually varying the main cycle. This one's 240 volts. You can get 110 volt ones as well, but they're pretty standard. There's loads and loads of these on eBay, and people use them all the time, and they're designed to be on all the time as well, using a very low power. So I feel pretty happy with that. Make sure you are. It's a 2-pin connection. I cut that off and put a normal main British plug on the end for mine. I also did a little bit of rewiring, because when you put it inside the box, when you've drilled the hole, you need to obviously get the cable out. So I did just have to do a little bit of rewiring inside, which was just taking the cables off the PCB and then soldering them back on. You might decide just to cut that off and put the feed directly on. It's entirely up to you, but again, just whatever you think is right if you want to make a heated version of this type of dry box. So we've got those two things. The next thing you're going to need is a little monitoring device, and I'm pretty sure this is very close to the same sort of device that Polymaker have used in their system. And all I've done with my 3D printed parts is make two parts that fit together, and actually you just push this bit into the front, so it just literally just pushes in and holds, and that just shows you the temperature and the humidity inside your box. Having this heater on constantly, 7 watts, keeps you around 32 degrees C or so, depending on your ambient temperature and the losses from the box, but it's pretty good. It keeps a nice constant temperature in there, keeps everything nice and toasty warm. So other than the 3D printable files, a spool that you can then print and use inside the box, you just need some desiccant gel, which I've left some space for under the design of the enclosure here. So then all you do is actually, once you've printed this out, this just slides into the groove and creates basically a curve that sits in the bottom that heats up below your filament. So you end up with your dry box that looks like this. There's a few cable connections at the front and one at the back. Cables obviously for the filament to come out. These are just oversized tubes to allow the filament to come out either at 3mm or 1.75. They're not Bowden tubes. They don't work in the same way. They're just literally for getting the filament out and safely to your 3D printer that might be a little bit out of the way. Quite important if you're going to use things like PVA, because again, you don't want it coming out into the open too much. You want it as much as possible enclosed and kept as warm as possible by the time it gets to your printer. So that's really it. I've used a seal on the top, which I actually designed and 3D printed. This is in NGen Flex. This is ColorFlab NGen Flex, just because it's a little bit stiffer than some of the TPU style materials. I wanted something that wouldn't just flop around, that I can actually, put on and help with the seal. Doesn't need to be completely sealed, but that just really helps create a nice tight lid seal and stops any vibrations and things like that. So I found that really useful just to finish off the system. And you can just see you monitor the temperature and the humidity as you go. So that's it really. I'll put the files up for the design of the plastic parts and the spool up on Imagine and Thingiverse. The other thing I did, because a lot of the time you just want to store a roll of filament, and if you've got a roll of filament lying around, people often, just take this one off, so people often put their rolls of filament in a bag, and I can sort of recommend, these are IKEA Ziploc bags that I use. They're really good. They've got a double Ziploc on the top, and this is a slightly bigger one. You can get a 4.5 litre one, which is a bit smaller, which is perfect size. But I was doing that quite a lot. Oh, the other one is the Rigid Ink bags are really good because they are metal inlines, so they're really good to use. But if you can't get those, just use any type of Ziploc bag. What I've also designed, which I'll put up as well, is a little holder for one of these monitoring devices that you can pop some silicone gel in the back. So basically all you do, print this out. It's a little 52mm spool holder. Take one of your monitoring devices, push it in, and it just clicks in like so. And then you can put that in the core of your material, and then you can slide that into your bag. And this is a great way, maybe with a bit more silica gel. I've put some in the back of this one, but this is a great way of monitoring your materials, because you can see on there what state your material's in, whether your bag's got a leak, an air leak or something like that, pulling as much air and moisture out of the environment inside. And that's basically almost identical to a polybox then, because you've basically got the same setup without the heated side of things. So that's quite a good small option if you don't want the heated side, but you want to keep an eye on your materials. That's a really simple little part I just put on to 3D print as well. But let me know if you make the actual heated dry box and how you get on with it, what materials you use. At the moment I'm testing some Colorfab PA carbon fibre, which is their nylon carbon fibre, which will benefit from having this type of warm environment to keep everything you know, nice and dry as possible. So those types of materials, nylons, PETs, all of those sort of things that absorb moisture, and especially any support materials, dissolvable support materials and other support materials which you'll be using as your printer goes on. And the thing with those is you might have a massively complicated print that's 18 hours and during 18 hours of it just being mounted on your printer, it can take on so much moisture and so much it can do so much damage to the actual coil of filament that you've got on there. So I can only recommend these because I've been using them for quite some time now and the design's stable. Okay, so do let me know how you get on with either this type of storage or the heated dry box if you decide to make one of those, which I can highly recommend. Okay, thanks ever so much for watching. Like I say, I've put the design files up on Imagine and Thingiverse. I'll put some links in the description below. So see you again next time.